Hello, this is Rahim Hussain. So in this video, I'm gonna show you how to implement FL learning. Uh, as you probably know, right, about FL learning, it's a new machine learning. It's a new type of machine learning. Uh, yeah, we will talk about more about it as we go along. So in this tutorial, our main goal is to learn how to kind of implement the FL FL learning. So basically, it would be like a presentation basically. So I'll try to explain everything that I've implemented, so that it's more clear. So as you can see, so in this file I have three in this folder basically I have three files. So one is like FL implementation utils, and then I have FL implementation. Then I have the data set, right? The swarm behavior data set. It's a pretty large data set. I mean, in terms of size, it has like 25,000 samples, and it has the features like 2,400 like features. Yeah, so it's a huge hit. Okay, in terms of, so let's go to the FL implementation utils. So in this file, I basically try to write all my necessary functions that I will be using in my training on the main script, right? The FL implementation script. So the first task, of course, is to like import all the necessary packages that I need, right? So then the first function is basically the load functions, right? It basically loads the data set. It takes the paths as an input, and then what it basically does, it's that. Okay, one thing to mention, I forgot, the dataset is already kind of pre-processed by me. So yeah, and then I kind of put it in a pickle file so that I can use it for my later purposes. So here I just unpickled the dataset. It's nothing but just to load it from the pickle file, right? So it's easier that way. So yeah, so all the processing of the data I have done it earlier. So yeah, so I'm not gonna show the processes of the pre-processing so here. So yeah, so the as I talked about data set, the last column of the data basically it consists all the classes, right? It basically it has all the classes of the data set, and then this is from the first column to the column before the last one has all the data, necessary data. So that's how I extracted the data and the levels basically, just using the simples, and then it returns the data and the levels separately. It's like a tuple format. It's not tuple, of course, but yeah, it kind of, yeah, it returns separately data and the levels. So yeah, so here as you can see, see if it is recording. Yeah, so here so I kind of set the data path. So it's pretty easier if we click the data set, and yeah, we can just copy the path and then paste it here. So it basically, so then we kind of give the data path to the load function, and then it returns the data list and the levels. Okay, so and then for the model building later on, we need how many classes are there, right? So we so how many unique classes are there. So I just calculated the unique classes, or just, yeah, calculated the unique classes here. So I need to do one extra step, I should say, because of the model compatibility, because I have two unique classes for this data set. So the model, the last layer of the model has like the shape of none comma 2, but the problem with this is that the label list actually has a shape of uh, 1 basically, right? It's a one long vector. So so when we kind of batch them, split them, it has like none comma 1. So it creates a compatibility issue when we feed them to the model. So basically that's why I had to do another step to make the classes into a two-dimensional vector, yeah, so that it has a shape, also has a shape of none comma 2. So that's why I just had to do this extra step. So then the easier part, right? I just split it basically, the training data, splitted the training data. So yeah, it's a very simple function. Okay, then yeah, okay, then a very important things to consider is that This is the next part is basically very unique to the federated learning, right? So so in the real world of implementation, okay, so the FL so each federated member will have its own data coupled, right, with its with it in kind of isolation, right? So the aim of FL is to kind of ship models to the data, not the data to the models, right? So the shared creation step here only kind of happens in experiments, right? So I'll share the training set into 10 kind of shards, okay, 10 or 10 clients, so to say. So one per client, right? So basically, yeah. So I wrote a function called create clients here. As you can see, it takes the data list, level list, and then the number of clients, okay, and then of course the initial will help us to kind of you know, to write the client's name basically. So here is the I'm creating the client's name here, right? Okay, so so here I'm creating the client's name using the prefix, right, initials, right? So the client names will have basically clients 1, clients 2, clients 3. It's a very simple thing, okay. So then basically on the next line I keep the data and the level list, then randomize the resulting tuple list, right? Randomizing is very important here, right? So of course, so finally I created the shards from the tuple list based on the desired number of clients. Yeah, I created this is the basically the shards, right? So yeah. So yeah, so basically then basically a dictionary containing each client's name as key and their data basically data shared as value kind of was returned, right? As you can see, it's just been returned like this, right? It's a pretty simple thing, right? So then yeah, we implemented it. Then yeah, this function has been kind of implemented here, right? Yeah. So create client list, we pass the train x train, y train, the number of clients and the initial, so it returns us a dictionary. The client is basically a dictionary, right? So yeah, so for the next thing, what you had to do kind of the basically is to kind of to process each of the client's data into TensorFlow dataset, right, and batch them. To simplify this step and avoid repetition, I encapsulated the procedure into a small function called batch data, as you can see here, right? I hope it's showing, okay. So it's a very simple it's a very simple kind of function, right? So you probably remember, right, each of the client data sets came out as a dictionary, right, as a kind of data comma level, right, tuple list from create clients, right? So I split the tuple into separate data and level list, yeah, data and level list, and then basically I then made shuffled and batched TensorFlow dataset objects. Yeah, this is fairly simple, I guess. Okay, then we of course we pass them. Each client has been passed through the batch data, and then the batch has been created. That's it, batch object has been created. So yeah, so for the test purpose, we just separately pass the test data set into this object, batch object. Yeah, so yeah, it will be used separately for the evaluation purpose next, okay. So yeah, so comes the kind of the next thing. It's called the model creation. So we wrote a simple MLP class, okay. MLP is basically multi-layer perceptron basically, okay. So we used 4-layer models here. So the first one consists of the 500 neurons, then we have 300, and then we have 200, and then it boils down to 2 basically, right? The basically classes has basically 2. So yeah, so the activation is also kind of pretty understandable. We used ReLU except the last one, because for binary classification sigmoid is the best, okay. Yeah. So yeah, this is a part of experiment. We need to play with it to see better results there, or maybe yeah. So I haven't got much chance to sort of experiment with this, yeah, but we need more experimentations on this, of course. so this is as you see, this is a very simple model creation using TensorFlow Keras. So then the comes the hyperparameters. So this is come around is basically the number of global epochs. As you all probably know that about the FL learning basically has a global server, then you have the lot of local servers. So the model goes from the global to the local servers, and then the training happens, and then the weights kind of come back to the global servers. So the come around is basically number of the global epochs, right? So then we kind of fixed our hyperparameters. As you can see, for the loss we kind of choose categorical cross entropy. So these are fairly simple things. Okay, so the thing is that then comes the model aggregation. So for the model aggregation, we wrote 3 separate functions, right? The weight scaling factor, and then we have the scale model weights, then the sum scale weights, right? So here comes the purpose. Is basically the first one was which is basically the weight scaling factor. It calculates the proportion of clients' local training data with overall training data held by all clients, right? And first we obtain basically we obtain the client's batch size here, right? And use that to calculate its number of data points, right? It's of course that. Then we obtain the overall global training data size, right? And then finally we calculated the scaling factor as a fraction in the last line. As you can see, this is our basically weight scaling factor, right? So next come the second function called the scale model weights. So it basically scales each of the local models weights based the value of the scaling factor calculated in the previous functions, right? So it takes this scalar is nothing but this, right? The weight scaling factor. So it scales the model weights based on that. Okay, so next come the sum scale weights. Okay, so it basically sum all clients scaled weight together basically. So these are the like very unique to our FL learning, right? So then I wrote the test, of course, for the testing purpose. There is nothing new in that. It's fairly simple. Okay, so here comes the training process. Okay, so the training is very important in FL learning, right? So the training logic basically has 2 main loops. The outer loop is basically this, right? This is our outer loop. So outer loop is the global iteration, of course, as I talked about it, and then the inner loop is basically for like iterating through clients local training, right? There is an implicit third one though. It accounts for the local epochs and will be taken care of by the epochs argument in our model.fit, right? So as you can see here, right? So we started by building the model, first calling the model object here, as you can see. Then we kind of build the global model here, of course. So the global model takes input it takes 2 parameter, of course. The first one is the input shape, of course, right? The input shape is basically the number of features. It's as our case I probably said it's 2400. Then the number of classes, it has 2 classes, of course. Then we build the model. Then we come here in the training things. Then we set the weights. First of all, we of course we get the weights. That's really important. And the weights of course are randomly initialized here, right? Then it has been shuffled randomly here. So the thing is that so when it comes to the client training part, it's basically, so for each client I created a new model object, as you can see, right? And compile it and set its initialization weights to the current parameters to the global. So this is really important here. We set the weights to the global weights. Okay, so the local models weights are set to the global weights, as I talked about it, right? So the model goes to the data, not the data, other way around. So model means basically the weights. So we set the weights to the global weights. That's really important. Then we started the training, right? So So after training, the new weights are scaled. And appended to the scale local weight list, right? That was it. That was it for like local training, right? Okay. So then we cleared the sessions. Then we basically scaled the weights, right? And then we kind of then we set these weights to the global model, right? That's how the training kind of takes place, right? So it's continue it's keep keep continuing till the till it reaches to the the comb rounds. So for for this experiment we just set it to the 10, so it will continue to the 10. So yeah, after completing each of the clients training, it will again so the global iteration will continue to the kind of the 10 times, and for there are 10 clients, so the training will be like fairly 100 times. So yeah. So then we kind of tested it in the training. During the training we tested it with the y test, right? How it's going, how it's performing. Then yeah, of course we wrote a simple model against the FL model, so to compare the performance, right? So this is it actually. So now it's time to see how it performs in action, right? So yeah, so let me just quickly go on and run it. So yeah, I'm running the FL implementation.py here. Let's see. Okay, I hope it's running good. Let me just to see the progress bar, you can use a simple thing called TQDM. It's available. It's a package, Python package. Okay, it's really good. So we can look at the global loss here. Okay, looking at the global loss, of course we can see it's learning, right? It's kind of the loss is decreasing. Okay, so the accuracy, we just took like 3 decimal values. So I think if we would have taken more than that, we could have also seen the results, right? So yeah, one thing may come to your mind that it's not very good result. Of course it's not, because we haven't done much experiment on the model and the hyperparameters, so we need to do a lot of things, and of course in the data as well. So we just normalize the data. So here we just normalize the data, right? So but yeah, so a lot of things could have done to the data, so basically to improve the learning. So yeah, so these are the things to be considered next. So but for now it's not doing really bad, so it's a quite easy. Yeah, you can see it's learning, right? Global losses is decreasing, sometimes it of course increasing. So yeah, let's see. So the 10 global iterations iterations are done, so it's waiting for the last part, the evaluation against. Yeah, so yeah, so the accuracy haven't hasn't improved much, or improved. The global loss has increased a bit, but it's not that of course it's not yeah. So another thing we could have done, we could have yeah, we could have put a random seed at the initials for the replicability kind of the result, I guess. Okay, okay, so we are waiting for the last part here. Of course we are waiting for this part here. So this is taking place. This is a simple model. We are passing all the data at a time to the model to see how it performs. Okay, so one thing is of course to be considered here is that the data is actually, we don't have much data. Okay, it's not enough data, right? Of course. So as you can see that the loss is a bit higher than our FL learning loss, but of course it's not much. It's not substantial enough to kind of see the differences. But yeah, we need more data. We need a good split of the data to see the differences. Okay, so if learning has a lot of data than the normal here, but a normal models, so here we basically use the same data. So yeah, so yeah, these are the things that to be considered it for the futures, but for now this is, I think, a fairly good implementation. So thank you for bearing with me so far.